Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod. In the last session, we have seen Mason's gain formula and the algebra regarding the signal flow graph. In today's session, let's solve a problem regarding the signal flow graph. In this particular graph or the system, we will find the transfer function. And we know the formula for this is overall transfer function equal to 1 by delta sigma pk delta k. Now, k stand for the number of forward paths. Step 1 is finding the number of paths. K equal to. Now when you see this particular system, you can see the forward paths from 1 to 2, from 2 to 3, 3 to 4, 4 to 5 to 6 and 7 and 8. And all the arrows are in the same direction. That is one path you can consider. And one more chance is like we start from 1 to 2, 2 to 5 in the same direction, 5 to 6, 6 to 7 and 7 to 8. Now one more chance is that 1 to 2, 2 to 3. But again from 3 to 5 that arrow is in opposite direction, so you can't consider it as a forward path. Now here 1 to 2, 2 to 3, 3 to 4 again in the opposite direction, so you can't take it as a forward path. We have the number of forward paths 2. Let's draw the graph here. That is starting from 1, 2, followed throughout till reaching the output node 8. R of S is the input node. 1, 2, 3, 4, 5, 6, 7, 8. Output node C of S. 1 to 2, that is 1. 2 to 3, that is G1. 3 to 4, G2. 4 to 5, G3, 5 to 6, G4, 6 to 7, that is G5, and 7 to 8, that is 1. This is for part 1. For this, the gain of forward path 1 P1 equal to, here gain between 1 and 2 nodes is nothing but 1 here, so 1 into G1 into G2 into G3 into G4 into G5 into 1. G1, G2, G3, G4, G5. For path 2, we have identified the path from 1 to 2, 2 to 5 and 5 to 6, 7 and 8. Let's draw that path. 1, 2, 2. This is 1 and 2 to 5. That is nothing but G6 followed by G4, then followed by G5, followed by 6, 7 and 8 and 1. The gain of forward path 2, P2 equal to 1 into G6 into G4 into G5 into 1. G4, G5 and G6. So you've got gain for path 1 and path 2. Find out what are the individual loop gains, because you are supposed to find out delta. Here you can see that you have loop from 3 to node 4 crossing only once, again ending up at 3. This is one loop. Individual loop. So I represent the graph for this is between 3 and 4 G2, and this is minus H1. So P11 is nothing but minus just G2 into H1, okay, P1 1. Now we'll go for one more combination from 3 to 4 crossing only once, 4 to 5 crossing only once, again in the same direction C ending up at 3. Okay, so this would be one loop. Individual loop 1. The second combination. Let's draw the graph from 3, 4 and 5. 3 to 4 is G2, 4 to 5 is G3. The feedback is minus H2, say. P21, product of the gains of this loop. Now that is nothing but G2 into G3 into minus H2. So H2. There is one more loop here starting from 6, crossing 7 only once, again return back to the initial node, that is 6. So individual loop, third combination. Let's draw the graph. 6 to 7, that's G5 and minus H3. So P31 would be the product of the gains, that is G5 into minus H3. Gain products of two non-touching loops. These are the individual loops. These combinations itself, you can find out the two non-touching loops. Now if you observe this loop and this loop, you have 3 and 4. This part is common. So definitely these two are not non-touching. If you see this one and this one, because between 3 and 4 and this is between 6 and 7. So definitely this is one combination of two non-touching loops. Combination of two non-touching loops. So 2. The very first combination is P12. Let's draw it. It is nothing but 3 to 4, that is G2 and minus H1, between 6 to 7 G5 and minus H3. P12, that is nothing but, this is P11 and this is nothing but P31. So P11 into P31. Here minus G2H1 into minus G5H3. That would give us G2, G5, H1, H3. Another combination of this and this one. You don't have anything in common here. This is between 3 and 5 and this is between 6 and 7. Second combination of two non-touching loops. Draw the graph. Now that is between 3, 4 and 5, G2, G3, okay, and then you have minus H2, 6 and 7, that is G5 and minus H3. So this one is P21 and this one is P31. So P22 is the gain products of these two. So P21 into P31 minus G2, G3, H2 into minus G5, H3. That would give us G2, G3, G5, H2, H3. Start finding delta. Now we know that overall gain equal to 1 by delta into sigma pk delta t. Now for delta equal to 1 minus sum of individual loop gains is nothing but individual loop gains P11, P21 plus P31 plus sum of all possible combinations of two non-touching loops. So two non-touching loops, you have P12 plus P22. We'll substitute this. That would be 1 minus G2 H1 minus G2 G3 H2 minus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. This would be 1 plus G2 H1 plus G2 G3 H2 plus G5 H2 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. We have got delta here. Now we should find out delta K. Delta K is nothing but delta further part of the graph which is not touching the kth forward path. We have K is nothing but number of forward paths, we have 2. So we have delta 1 and then delta 2. Now if it is delta 1, apply this delta formula whichever part which is not touching the path 1. The path 1 is from 1 to 2 followed by 3, 4, 5, 6, 7 and 8. So there is no part of the graph which is not touching this forward path 1. Delta equal to 1 minus, you don't have any of the terms here, would be 1. Delta 2. You are supposed to find out delta for the part of the graph which is not touching the forward path 2. This is the path. Here if you can see between 2 and 5 there is part of the graph that is between 3 and 4. But it's not between 3 and 5 because anyhow it's touching with the node 5. So this whole part of the graph is not touching this forward path 2. So for this part of the graph which is not touching this particular forward path, you are supposed to find out delta. That is 1 minus sum of individual loop gains. So there is only one loop here between 3 and 4. So that would be 1 minus P11, 1 minus G2 H1 would leave us 1 plus G2 H1. Substituting and find out the overall gain or the transfer function for this particular graph or system. 1 by delta K equal to 2 in forward paths. So that would be sum of P1 delta 1 plus P2 delta 2. 1 by delta anyhow we have found out 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. So P1 nothing but G1 G2 G3 G4 G5 into delta 1 is 1 plus P2 is nothing but G4 G5 G6 into delta 2 is nothing but 1 plus G2 H1. Multiply and simplify this. The final transfer function or overall gain of this particular system. On the whole we have seen finding the number of paths, then finding the individual loop gains, then finding the combination of two non-touching loops, non-touching loops, and if you have 3 combination you have to find out 3 also. Okay, now after getting all the data and the path gains also, then finding delta, then find out delta k, then substitute and t equal to 1 by delta sigma pk delta k. If you do have any queries, please mention in the comment box below.
Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.